adding, subtracting, and multiplying polynomials. Basically, combining like terms and foiling to a certain extent. So whenever you're adding or subtracting with polynomials, you have a choice. You can do it up and down, you can do it vertically, or you can do it side to side horizontally. Now I know, in the book, it specifically has for you what?
Thank you, Mr. Harty.
It specifically has for you, you know, add them this way or add them that way. If you find one way that you like better, I say do them all that way, but that's just me. Like for instance, when I'm trying to add these vertically, notice they're lined up with like terms. That's important when you're doing it vertically. But when I'm adding, you just add down. But be careful, you are not multiplying here. Don't mess with the exponents. You're just combining like terms, basically. 2 minus 10 is negative 8. Nothing to add to my negative x, so I guess I'll just bring that down. And then negative 7 plus 8 is 1. That's all I can do. I've got all my like terms together. If I'm doing it horizontally, this is the way we're more used to seeing it, like in a book or something. And I'm going to combine like terms, but be careful that the terms are like. I only have one term here that has a cubic, so that's the only one that's going there. Okay, x squared, I only got one of those. X's, I have multiple terms that I can combine though, and again, signs matter. It's that sloppiness on there that could burn some of you here. So watch your signs, but again, otherwise, that's it. Now subtracting, I am very much more a fan of horizontally. Because people, when they tend to subtract vertically, well, I'll show you what happens here. Most people are okay with the first one. They're like, okay, 8 minus 2 is 6, okay. And then they forget the minus signs there. Because this is negative 3 minus 6. It's changing the sign on all of these is basically what that minus is doing. So negative 3 minus 6 would be negative 9x squared. Negative 2, switch the sign. Negative 2 plus 1 is a negative 1x. 9 minus 1. 9 plus negative 1 is 8. Again, not a huge fan of doing it this way, just because there's too many little places where you can make a boo-boo. Because when I see it horizontally, I automatically either do this to remind myself the minus goes to each, or if I'm really feeling a little bit about the whole thing, I'll literally change the signs on all of them and then just add horizontally like I did up above. Again, it's the things that seem to be the easiest that will get you the most or get you the hardest when it comes to a quiz or a test. So you really want to watch your attention to detail on these just to make sure things are going okay. Now multiplication then is its own game. Multiply two polynomials. Each term of the first must be multiplied by each term of the second. Okay, so if I want to do it this way, what I could basically do is say, I'm going to distribute what's below to each term up above with these. So like here, if I started to distribute, I'd have negative x to the third plus 2x squared plus 4x. And then I would do the same thing with my last term. Now notice it's negative 3 times negative x squared. It should be positive 3x squared. I'm going to line up the x squareds underneath each other. Negative 3 times 2 is negative 6x. Negative 3 times 4 is negative 12. So it sets up a little bit offset, but my like terms are lined up at least. And then I can just add down to combine like terms. Don't mess with the exponents at this point. And I can get an answer. And some of you are going to be very comfortable doing something like that. Some of you here don't mind going arrow crazy with this, doing all of your distributing for all of these. But let's say some of you are like, that really starts to confuse and irritate me. Here's an option for you. I always like to put options out there just in case. If organization is one of your deals, and you want to do all the multiplying out, but you want to do it in a little bit neater of a fashion, here's a plan for you. You can make yourself a box. And basically what it's doing is it's making sure you do each of the distributions. Because as you fill in the boxes by multiplying what's on the outer edge of that box, you're doing all of the distributing that you would need. Negative times positive. And there's actually a bonus with doing it with this box. Your like terms are always going to get arranged for you. Your greatest exponent, and then each diagonal after that is going to be your like terms that you're putting together. Now again, if you can do all this in your head, that's fine. I don't care. But again, the nice thing here, as long as I'm careful, because again, once the box is filled, multiply to fill the box, add, or combine like terms after that, and you can get to an answer. And that would work with this as well. You just have a 3 by 2 box. You can make a box of any size. 2 by 2, 3 by 3, 5 by 5, it doesn't matter. So the nice thing with that is it's a little bit flexible for you, which is always a nice thing. She's like, well, wait a minute, Harty. You're going to tell us there's a 3D box next? Because now there's three binomial terms here. No, can't do that. Okay, you have to take these on 2 at a time. So for instance, I'm going to FOIL my first pair out first. So if I did that, let's see here, x squared plus 4x minus 1x is plus 3x minus 4. Once that first one's set, then I can bring the last one in. And again, if you're comfortable just foiling your way through and then combining, that's okay. Or if you like the new box method and want to do another 2 by 3, you can. So I guess I'll do this one old-fashioned just so you can see how you like it. So if I go distributing, let's see, I'd have x to the third plus 3x squared minus 4x, and then I'd use the 3 and I'd go along the bottom here. So 3x squared plus 9x minus 12. Now the one disadvantage with this is I don't have all my like terms together. I got to go find them. So let's see, x to the third, okay, I only got one of those. 3x squared and 3x squared is 6x squared. Negative 4 and 9 is 5. Okay, still wasn't bad. Not quite as organized as boxes, but again, everybody's got their own thing. And then 8 is similar to 7 in that I really do have 3 sets of binomial terms there. Again, don't get sucked in here to writing down x squared plus 25 and think you've multiplied it out. So, if you can think of it off the top of your head, that's fine. Otherwise, write it out and multiply it out. So let's see, x squared minus 5 and minus 5 minus 10x. Negative times negative is positive. And once I get that taken care of, again, distribute, box, don't care. I'll try a box this time. I'll kind of mix it up here. They both do the exact same thing. It's, again, for some of you that get out of control on your papers and have work everywhere, this might help you out to stay a little more organized. And then I'll just clean up. Get my like terms lined up here. And I'm good. Let's see here. As long as you can multiply or FOIL out with these, The next part, the special products, are more those things that, well, it'll save you some time if you know them, but it's not going to kill you if you don't. Like what? In other words, when I'm looking at special patterns, differences of squares, how they work out, and the sum of sums and differences, I could, if I wanted to, FOIL this out. But again, if you know the pattern with one like this, basically it's square the first term, 2 times x is 2x, double it, 4x, and square your last term. I'm done. It's the same thing I would get if I were to actually write it out and then FOIL it out. X times x is x squared, 2x, 2x, 4, and then combine like terms. So again, it doesn't matter which way you do it, but if you see the pattern, it can make things go faster. So like for instance on 10, I square my first term, so 9x squared, keep my sign here. 4 times 3 is 12, double it, 24x, and then negative 4, or 4 squared, is 16. I'm done. Again, FOILing gets you to the same thing though, so if you don't remember it, no worries. And then finally, my difference here, same terms, just one's plus and one's minus. Square the first one, square the last terms, so x and x, 7 and 7. Put a minus in the middle. So if you see the patterns, use them. If you just go through and you're not worried about it, well, FOIL them out. No big deal. Now the one in the back though, this gets a little more interesting. Now again, I'll show you both ways. You can either look at this as 3, x plus 3's, and FOIL the first two out and then box it out again. Now this one's going to show you it's probably better to know the form. So if I were to FOIL that out, then I still have to deal with this. It's like, ooh, it's going to take forever. So you'd go along and you're like, okay, hopefully there's not a lot of these on the quiz. Because this is just, it's not so much the time constraint, just how much writing you have to do. Now, before I even combine those, I'm going to show you the pattern because you're going to see where the answer comes from this way. You're going to be like, ah, now I see. When you're doing the cube of a binomial, okay, this a and b, so like in this case, my a value would be x, my b value would be 3. Watch the pattern that develops. Like for instance, my a, okay, my first term is this term cubed. Okay, so x cubed, got it. As I start going along, I start noticing something. I'm like, well, wait a minute. 3a squared, a, no a left at all. Oh. So a squared, I know I'm forgetting something, but just stick with me. A, none of them left. Well, what about this b then? Well, there's none in the first one. Well, now I'm up to 1, so that'd be a 3 that goes here. Okay. Well, now it's squared. Oh, this is going exactly the opposite way that that one did. And then 3 cubed. So my a term goes 3, 2, 1, 0. My b term goes 0, 1, 2, 3. And as long as I remember that 3 coefficients there, 3 times 3, 9x squared. 3 squared's 9, plus 3 is 27. And 3 cubed is 27. And I look, x to the third, 6 plus 3 is 9. 9 plus 18 is 27. Well, hot dang. It doesn't, like I said, it doesn't matter which way you do it. It doesn't. But if you can pick up on the pattern right away, it's kind of cool to be able to do it that fast. So if we go strict pattern on 13, so I'm like, okay, so my first one is cubed. But then notice if it's minus in the middle, this sign right here becomes minus. So minus, I'm going to have 3a squared b. Now be careful. My b value is not negative 5. It's 5. So times 5 plus 3a b squared minus b cubed. Again, my a's go down by 1 degree each time. My b's go up by 1 degree each time. But you've got to admit, let's see, 4, 20, negative 60. You've got to admit the speed of this, 25 times 2 is 50, times 3 is 150. The speed's a lot better than having to do all of that, you know, FOIL it, multiply it out again, combine like terms, write it versus bang, there it is. But again, it's personal preference, so I'm not too worried about it. Now, part 5 is the problem most you would skip on a homework check that I start wanting to whack points for. So, all right, let's see if we can take care of this and make it as easy as it is. From 1985 to 95, the gross farm income, G, and expenses, E, in the United States can be modeled by, where T is the number of years since 1985. Write a model for the net farm income. Okay, net farm income. Income minus expenses. As you get older and have to deal more and more with taxes, you'll understand the difference between gross and net. Gross is how much you make. Net is what you have left when the government takes all theirs. So if I'm just writing a model for this, I'm just taking my gross and subtracting my expenses. And whether you wanted to do that vertically or you want to do it horizontally, doesn't matter. But you do have to remember to actually distribute and combine like terms. So let's see here. Leave this guy alone. Distribute that negative. Make sure it makes it all the way through that second half of your problem. And again, just go into combine like terms mode. See, and this is the problem. Like I was saying before, a lot of you will just skip on the homework. Oh, it's a story problem, don't care. Don't do that to yourself. Because again, those are the things that come back to bite you on a quiz or bite you at least point-wise on the homework check. So just watch out. Even this next story problem, nothing big. We're raising money for a trip to Spain, and you decide to sell cookies. The revenue from selling cookies is given by the equation R of x equals 2.5x. In other words, I'm charging $2.50 per cookie. The cost for making x cookies is given by the equation C of x equals x plus 32. So however many cookies I make plus 32 is going to be how much it costs me. Oh, I kind of answered my own question at first. How much are you selling each cookie for? Well, $2.50. Every cookie, I get $2.50. Write a profit function, sort of like what we did here. Revenue minus cost equals profit. Now, that's not the profit function. That's in general what they look like. So my revenue minus my cost is going to be what my profit is. But again, I need to simplify. So 2.5x minus x would be 1.5x, and then that negative would distribute to my 32. Oops, P, Harty, P. So however many cookies I sell, I would just stick that in here for x, and it would let me figure out how many cookies I needed to make. What's your profit for selling 381? Plug it in for x. Looks like I make about $539.50 for my trip. Not too shabby. And then the review's just the bottom because I'm going to start spiraling some things back in as we go through some of these units so we don't forget. Because before you know it, finals will be here and, well, shoot. So let's see here. When I'm going power to power with my exponents, what do you do to the exponents? Ooh, it's good for doing this. Nope, if we're just straight multiplying, we'd add them. Power to power? Because here, if I distribute this negative through, this becomes minus x minus 32. So when I go to combine like terms then, 2.5x minus x, or minus 1x, that's where the 1.5 is coming from. Yep, backed up there on the profit function. But we're still in our other quandary. What am I doing to the exponents? It's not adding. Multiply. So this 4, yes, it still goes to the 4, and then it multiplies times my exponents on these others. So I've got 4 to the 4th, x to the negative 8th, y to the 20th, and of course I have to simplify this. So 4 to the 4th is 256, again not 4 times 4. Y to the 20th gets to stay here. What about that negative exponent? Don't like negative exponents. How do I make the negative exponent positive? What can I do to it?
Can't you take an I out?
If we were taking a square root, I could take an I out. But in our case, I make it behave and become positive by flipping it. So since anything that you write always can be made a fraction by putting it over 1, by moving that to the denominator of the fraction, I've flipped it and got it where I need it to be. Now sometimes I can do those individually. Other times, if this whole thing is to a negative exponent, it might be easier to flip the whole thing at the start, which would make the 2 a positive exponent once I flipped it. Now I still got to distribute it through, but at least now I don't have to worry about negative exponents anymore. So negative 2 parentheses squared would be 4. 2 times 3 is 6. Yes, even to the b, so b squared. And 6 times 2 is 12. No other like terms, no negative exponents. Woo-hoo. So, okay, let's see how we can tackle this next one here. We know the negative exponent's got to flip. Okay. There's no other b's anywhere. Okay. How do I deal with dividing with a like base? Any ideas? We haven't gotten to the adding part yet. So here, when we're dividing, you're going to subtract your exponents, but always do the bigger minus the smaller, and then put your answer where the bigger one's at. So with my k's, 6 minus 3 is 3. The bigger exponent's in the denominator, so that's where it goes. You're like, but wait a minute, there's nothing left up top now. Sure there is. And I have to put the 1. If I just circled this, I'm saying it's all up in the numerator, and that wouldn't be correct. So if we wipe out everything, up top I got to put that 1 in to hold the place. And you're like, okay, these rules, it's been too long ago. But again, power to power, if that exponent's outside the parentheses, we multiply. Don't like the negative exponents. Flip it on down. Do I flip the k to the third? No. Nothing left up top again. Gotta leave it. And then lastly, you're like, oh, not another negative exponent. Make sure it gets to everything. Negative times negative is positive. 2 times negative 4 is negative 8. 3 to the negative 4th we'll deal with in a minute. I've got m to the negative 4th, p to the negative 12th. That's a whole boatload of negativity. Don't like all this negativity. So my first job, instead of trying to combine everything right away, I'm just going to deal with all the negatives. M to the 8th, you're the only person that gets to stay. Everybody else is moving so they can be more positive. And once I get here, now I can use my exponent rules to simplify at the end. 3 to the 4th is 81. Now that I'm just multiplying those m's together, this is where I add. So 8 and 4 is 12. And the p's I'm dividing, so I subtract. 12 minus 8 is 4. Bigger exponents on top. I could put it over 1, but I don't have to when they're up in the numerator. Then again, just those of you when you're trying to give yourself a reminder of what's going on here. This is going to be number 2. I should laugh and see how fast I can make some of you right. I should have been doing this during the lesson. I'm going to start sending the seating chart around. This ought to be interesting. If you don't get it before you go, mental picture of where you're sitting right now so you remember. So it's like the class quiz for the day. Can we fill out the seating chart and not get me all confuzzled with it? All right. Who cares?